This is 6.2, lines of fit. So a line of fit is a line drawn on a scatter plot close to most of the data points. It can be used to estimate data on a graph. So we use this a lot when we have scatter plots. And here we have the table shows the number of absences in a school year and the final exam scores for several students. We are going to make the scatter plot, and then from there we're going to write an equation of the line of fit and interpret the slope and the y-intercept of the fit. So I have all of this data, and when I plot it here, you can see that all these little orange dots, they kind of have a trend of a negative linear relationship. So first it says draw the line of fit. So I chose to draw this pink line here, and it's going to have to go through as many points as possible. And then we are going to also balance how many points are above the line versus how many points are below the line. So this one has a few more underneath, but this is the line that's going to be able to go through as many points as possible. Then from there, I can see that the line goes through 0, 97, and 970. I just chose 2 points that it crosses through perfectly. And to write my equation, we need slope-intercept form. So use your formula to find slope, which is -3, and the y-intercept is where it crosses the y-axis, which was 0, 97. And then we plug it into slope-intercept form, and this is my equation of the line of best fit. So we can say that with 0 absences, a score of 97 is expected, and the score decreases by about 3 points per absence. So that's what the slope means. This example says the table shows the number of goals scored and number of games won by 8 hockey teams. We are going to use a graphing calculator. In this case, we're going to use Desmos, desmos.com, to find an equation of the line of best fit. Then we're going to identify the correlation coefficient. So we're using a graphing calculator because these numbers are quite large, and when we plot them, it is difficult to find all of the lines so that it is balanced in between. So when we go to Desmos, it tells us the slope of this is 0.27, and the 7 repeats. So it is positive, and the y-intercept, so down here, is at -22.88. So this would have been fairly difficult to calculate by hand. So using a graphing calculator for these numbers makes it simpler. It said to write an equation, so it gives me slope and y-intercept, which we plug in straight to slope-intercept form. Then it also said to identify and interpret the correlation coefficient. So the correlation coefficient is R in the box of data that it gives us, and it was 0.9772. A correlation coefficient can go from -1 to +1. The closer it is to 1, in either positive or negative, the stronger correlation it has. So the closer to a line, perfect line that it has. So since this is 0.97, this is a strong positive correlation because it's a positive slope, and the equation closely models the data. So this equation closely models the data that we have given. On Desmos, to find that, here are some tips or directions to help you find all of these 3 pieces of information.